the right place. This is a webinar on reducing life cycle greenhouse gas emissions from road construction and maintenance. This webinar is brought to you by the National Center for Sustainable Transportation and the Policy Institute for Energy, Environment, and the Economy at UC Davis. This webinar builds upon the work and findings from a white paper from our authors that are presenting today, and this white paper and associated policy brief will be posted next week, so please be on the lookout for that, and we will send out an announcement to everyone that registered for the webinar when those documents are ready for download. For today's webinar, we will spend the first half hearing from our speakers and featured guest respondents, and then the second half will be for Q&A with participants. So please be thinking of your questions now. And as you can probably tell, everyone is on mute. So if you do hear any distracting noises like dogs barking, people talking, then you know who to blame. It will be us. So if you do have questions, please share those in the chat box that you'll see in your lower left-hand corner. And you will see some of the message that we're sharing with all of you about calling in at this number, which if you're hearing me now, you've called in and used the right number. So now, without further ado, I would like to introduce our speakers and special guest respondents. So our speakers today are John Harvey and Alyssa Kendall, both from UC Davis. John Harvey is a professor of civil engineering at UC Davis and is the chair of the Transportation Technology and Policy Graduate Group. He is the director of the University of California Pavement Research Center, which has an ongoing Caltrans Division of Research and Innovation sponsored project for research and development of a wide range of pavement technology. Alyssa Kendall is an associate professor at the Department of Civil and Environmental Engineering at UC Davis. Her research interests focus on evaluating the material, energy, and waste flows generated by engineered systems and refining and enhancing the methods used to evaluate their impacts with a focus on transportation systems and climate change. We're also very excited to be joined by two leaders in the field as our special guest respondents. We have Heather Dilla, who recently joined the National Asphalt Pavement Association as the Director of Sustainable Engineering, where she manages programs that assist producers, contractors, and designers in improving the overall sustainability of the asphalt industry. She currently serves on the Federal Highway Sustainable Pavement Technical Working Group and is a technical advisor for several research projects. We're also excited to have Deepak Maskey, who is a transportation engineer in the Office of Concrete Pavements and Pavement Foundations for Caltrans. He oversees technical issues pertaining to the concrete pavements and bases. In addition, Mr. Maskey is a technical lead for the development of environmental sustainable pavements and life cycle assessment for Caltrans. So without further ado, I will turn it over to John and Alyssa.
Good morning, everyone. This is John Harvey, and I'll get us started. So we'll be talking about the reduction of life cycle greenhouse gas emissions from road construction and maintenance and the role of life cycle assessment. We're advancing the slide here a little slow. So we'll take a look at the purpose of the white paper. We'll talk about LCA development, standardization, and the application to pavement. We'll take a look at the definition of the pavement system and its life cycle. We'll look at the kinds of questions that can be answered regarding pavements using LCA, a little discussion of where we're at and where we need to go, and then look at recommendations and conclusions. So the purpose of this white paper is to give an overview of the role of pavement LCA in understanding and developing solutions to environmental impacts of pavement systems. What we'd like to try and do today is begin to inform you about pavement LCA and then recommend some actions. In doing that, we're going to review the state of knowledge and state of the art in modeling and analysis using pavement LCA, and then try and take a look at where there's agreement in how we do this, as well as the areas of emerging knowledge and discussion. Always ask students when they're looking at a new subject, they should always ask the question, so what? So this is the so what part. Why do we care about the environmental impact of pavements? In the United States, we have 4 million miles of public roads. 2.65 million of those miles are paved with either asphalt or concrete. The rest of those are gravel or dirt roads. These roads provide mobility and access. We drive 3 trillion vehicle miles each year. The value of these roads carry about 67% of all the freight in the U.S., and that's in terms of both tonnage and in terms of dollar value. More than 300,000 people are employed in the construction, maintenance, rehabilitation, and associated industries associated with roads. We spend about $182 billion a year on highways, and we have a very diverse set of owners and decision makers across state and local government, private and institutional owners, and the federal government. And what we'll be talking about today with Pavement LCA applies to all of those pavements: government, private, state, local, federal. In terms of the energy used each year, the vehicles moving on pavement burn 169 billion gallons of fuel a year. And if we can have some influence on that with pavement, we can have a pretty significant impact. We use, in terms of tons, these are millions of tons of materials each year. We use more than 1,200 million tons of crushed stone, 987 of sand and gravel, 21 million tons of asphalt binder, and 72 of cement, including bridges. Now, one of the key things with regard to pavement is that nearly all of these materials are recyclable and can be recycled multiple times. Now, we know that coming out of the pavement system, we have emissions in terms of greenhouse gases and air and water pollutants. In terms of the material flows that we have, as we can see, this is looking back more than 100 years. We can see the tremendous growth in the amount of resources that we're using each year. And this has grown with increasing traffic demand and the building of new roads. In the United States at this time, we have a pretty mature system. So we're not building that many roads, but you can see that the flows have not gone down that much because this is a system that is designed to be maintained and rehabilitated on the order of every 10 to 40 years. And the demographic of our network is that it's aging. In terms of greenhouse gas emissions, we can look at the sectors from which greenhouse gases are emitted, and this is a national pie chart. We can see that transportation is second only to the generation of electricity in terms of U.S. greenhouse gas emission sources. And in addition to the vehicles that are operating, contributing to transportation sector, we also have our mining sectors, our oil refining sector, our cement production sector, and the other associated sectors in the other parts of the chart that are part of the road building system. In addition to greenhouse gases, and we do tend to focus a lot on greenhouse gases and energy, we also have other pollution problems in the United States, some of which can be at least partially addressed through pavement and how we manage it. This shows 8-hour ozone non-attainment areas by county in the United States, somewhat regionalized, but heavy on California. So for those from California, particular attention to that.
So I'm going to tell you a bit about life cycle assessment. So life cycle assessment is a method for characterizing and quantifying environmental sustainability, and it takes a cradle-to-grave perspective to do this. It also attempts to consider system-wide impacts of a product, policy, or system. And the purpose of an LCA is typically to either compare the performance of alternatives, to anticipate unintended consequences of a decision or technology, or to identify hotspots. Hotspots are those parts of a production system or life cycle that can be targeted best for improvement. There are some international standards out there for life cycle assessment, or LCA, and the most widely cited are those from the ISO. These include their 14040 series. Unfortunately, these standards are intended to apply to any product, system, or policy, and so they provide only general guidance. And a note on life cycle assessment, a lot of times we hear the terms carbon footprint or energy footprint, and take note that these kinds of footprint analyses are basically a narrow form of LCA where we only look at one environmental impact category. So in the case of carbon footprints, that's carbon dioxide equivalency or global warming potential. And of course, for energy, it tends to be total primary energy consumption. So if we think about what happens during a life cycle assessment, one way to think about it is an accounting process. We're looking at material and energy inputs and waste and pollution outputs occurring at each stage of a life cycle. So we always start at raw material acquisition. So for a pavement, this might be an oil field or a quarry, for example, material processing, manufacturing of materials, and construction of pavements, then use of the system or pavement, and end of life. End of life refers to the end of service life because we always want to think about what happens after the end of service life, which could include reuse of materials, remanufacturing, or recycling. The ISO standard and many other life cycle assessment standards out there usually conceive of life cycle assessment happening in 3 stages, the first of which is goal definition and scope. This stage requires that the practitioner actually select a modeling system boundary. It essentially defines what is going to be in or out of the life cycle assessment. It's obviously a critical stage in determining what the life cycle will look like. The second stage is a life cycle inventory assessment. This is really the accounting stage. This is where all the inputs and outputs are tracked from the system. And usually those inputs and outputs include primary materials, secondary or recycled materials, and energy. Other inputs can include water, land use. Outputs include air pollutants, water pollutants or effluents, and waste, solid waste. They also includes co-products. Co-products are those products produced alongside whatever product or system you're looking at, but they can also be co-services. The final step in life cycle assessment is impact assessment. So imagine at the end of this life cycle inventory, you have this big spreadsheet of resource inputs and pollutant outputs, but it's hard to conceive of what that really means. And so in this stage, we translate that inventory into meaningful impacts or indicators of environmental and human health. The way we do this is we take that inventory output and we assign the pollutants or resource inputs to different impact categories. So for example, here we have CO2 being assigned to climate change, particulate matter, SOx and NOx to respiratory effects, and mercury emissions to human toxicity. This is obviously just a subset of the environmental flows that can be tracked in a life cycle assessment. The US EPA actually has an impact assessment method, the TRACY, the tool for the reduction and assessment of chemical and other environmental impacts. And they conceive of these different impact categories in three sets: impacts to people, impacts to ecosystems, and depletion of resources. So this is an example of one impact assessment method that can be used and has been tailored to US conditions. The last part of this 3-step assessment process I'm going to talk about is interpretation. Interpretation should be happening throughout an analysis, which is why I didn't talk about it as a distinct stage. But of course, at the end of an analysis, the interpretation of results is going to be the basis for conclusions, recommendations, and decision making, and is obviously a critical decision for the practitioner. So if we take this very generic framework that I've described and we think about what a pavement life cycle looks like, we obviously have material acquisition and production as an important stage. Transport of these materials, many construction materials are heavy, so transport can be important sometimes. Then construction, which includes maintenance and rehabilitation of the pavement. And here we want to think about transport, so mobilization of equipment and transport of materials, equipment use, and then traffic delay if traffic delay is induced by the work zone. We also want to actually just think about work zone effects more generally, not just delay. During the use phase, we might want to, we want to consider the effect of the pavement on users and the environment. So how does the pavement interact? And so one example is rolling resistance. So the pavement can affect rolling resistance for the vehicles that use it and thus affect vehicle efficiency. Albedo, which can contribute to urban heat island effects and also affects the lighting requirements for the pavement. Leachate and carbonation processes are other examples of use phase processes. And then for during the end of life, we will always want to think about pavements. We might just demolish a portion of the pavement, so that portion of the pavement has reached its end of life. And of course, we have options to recycle or landfill that material. And in all cases, we want to track transportation when we're moving those heavy materials around. So one question is why we might want to use life cycle assessment instead of some other methodology for environmental performance. The first is that we get quantified outcomes. That means we get actual numbers rather than qualitative descriptions of the environmental performance of the system. In an LCA, we want to always use project-specific inputs when we're evaluating a project, and that means that we can make project-specific decisions about things like materials, transport, construction processes, and understand traffic levels to best make decisions about our processes. Also, because we can generate multiple impact categories, it requires explicit prioritization of outcomes for decision making, meaning we can actually use LCA to help prioritize outcomes and thus guide decision making. And finally, because we can do site-specific analysis, we can account for regional and time variability, and then of course we'll need to address uncertainties in data and analysis. So I've talked about the ISO standard, which is a global standard for all products and not specific or individual products. But there have been some standards that are emerging for pavements in particular. So Europe, for example, and which has both a European standard but also national standards, for example, Norway, Netherlands, France, and the UK, which assist LCA practitioners. And then in the US, the UC Pavement Research Center here at UC Davis has come up with guidelines starting in 2010. And then the Federal Highway Administration is expected to publish guidelines in September of 2015. So here's this is an example of some of the work that was done at the UCPRC to assist in the development of pavement LCA guidelines. We convened a workshop in 2010 here at UC Davis with an international consortium, and then in 2014, another one here in Davis, California, and in between we had a meeting in Nantes, France. And again, here's a report from the Federal Highways Sustainable Pavement Task Group. This report was published in February 2015 and covers all pavement life cycle phases. And LCA guidelines from the same group are expected by September 2015. There are also a number of tech briefs and webinars through this program that are available.
Regarding the Federal Highways webinars, there have been 2 so far. The next one's in a couple weeks, looking at more sustainable concrete pavement practices. Some example scenarios where we can use LCA to look at some pavement decisions. We need to think in terms of some different levels. At the network level, when we're managing the entire pavement network, some of the questions that we can look at and have been looked at include the timing of maintenance and rehabilitation treatments to minimize greenhouse gas emissions and energy use, looking at different funding levels in terms of the impacts on environmental emissions, and in terms of developing general policies for application at the network, for example, in the decision trees of the pavement management system, or dividing up the money between new construction, rehabilitation, preservation, and maintenance. At the project level, you get down into many more details. At the project level, with a good LCA tool or database, or even just general LCA thinking, if we don't have the detailed databases and tools yet, we can look at the selection and design of pavement structures, evaluate different recycling strategies, look at the impact of designing in a longer pavement life versus a shorter pavement life, where we get our materials, and how we haul them to the site. And one of the key things about LCA is that there are some general rules of thumb about what will reduce emissions and make pavements more sustainable. They're not always true, and the ability to use project-level LCA to find and make sure that those general principles are actually applicable and going to give us the result we want for a given project is very important. When new materials are proposed, new structures, new construction approaches, we can use LCA to evaluate the environmental impact of those, and then we can look at some major issues, some very large system issues, and the interaction of pavement with the built environment, particularly in urban areas, things like heat islands, water cycle effects, and the effects on lighting energy. Now, there are gaps. A lot of the workshops that Alyssa was talking about were identifying gaps and finding common ground and trying to fill those. One of the most important is the sparseness of the life cycle inventory data for North America. Most of the data that's out there that's high quality is proprietary and therefore costly, which makes it harder for it to be used routinely. So one of our major gaps is to support the development of low-cost, high-quality inventory data. Some of that data is not regionally applicable. Some things are different in different places, especially for materials production, construction, and recycling treatments. And then some of it may not be completely up to date. Some particular examples are warm mix additives, which are being used widely. Some concrete additives being used widely that have some major benefits, but we don't necessarily have the life cycle inventories for them. In the use phase, the main modeling gaps are deflection energy dissipation. How does the pavement structure itself interact with the vehicles in terms of fuel economy? And modeling of the effects of pavements on heat island and what's the net effect of changing the pavement system versus the benefits that might come from reducing the heat island. And then the third area is really figuring out the accounting system for recycling, particularly when we're recycling materials from other industries. At the implementation, in the implementation area, the gaps are how do we bring LCA into the decision-making process? The two main countries that have used it in Europe are the Netherlands and France to date. Now, they're mostly using design-build or design-build-maintain systems of project delivery where the contractor submits a bid that includes a life cycle cost analysis and an environmental life cycle assessment. But the bidder can change the design in order to optimize both of those. In the United States, we primarily use a design-bid-build method of project delivery where the design is done and may be optimized, and then it's put out to bid for the contractor. So there's something of a disconnect between the contractor who's supplying the materials and the designer who's designing the pavement structure. What we need to do is figure out how to bring LCA into the low bid environment. Some of the decisions regarding some decisions that can be evaluated using LCA include policy development, design guidance for the project level, project management guidance for the network level, design decisions in terms of selection of designs. Currently in California, for example, and many other states, the pavement type is selected based on life cycle cost analysis. Once we have enough data to be able to make decisions, we can make decisions about major pavement types, design lives, and then some major decisions within types of pavement as well, and eventually get that into the procurement process as has been done in the Netherlands and France. One of the ways in a major a place where there's a lot of innovation and movement right now is in the development of product category rules, or PCRs, and environmental product declarations, or EPDs. PCRs are basically the rules that an industry sets for itself to guide industry members how to do life cycle assessment. And the purpose of the life cycle assessment for the industry members is to produce environmental product declarations. An environmental product declaration is a statement by a producer of a product, which could be a pavement material, a component pavement material, any kind of product that says, here's my product, and here is the list of flows and impacts for my product. PCR's, product category rules for pavement materials, are specific to a material. They're typically cradle to gate, which means the person producing the EPD following the PCR, I'm going to throw a few acronyms at you, is typically only responsible for the environmental impact up to the point at which they hand it off to the person who's buying their product. So that's what we call cradle to gate. PCRs and EPDs are available for many of our basic materials. They're becoming more prevalent. Much of this is being driven by points being given in LEED version 4 for EPDs. For pavement PCRs, at this point we have PCRs for cement and concrete, lime and aggregate in place. So these are the PCRs that we have in place, and PCRs are under development for asphalt and asphalt mixes. Just to give an analogy, this is not actually what it looks like, but the analogy of an EPD is when you look on your box of cereal and you get a statement that's certified and was developed following certain protocols of what the nutrition is within that product. So the idea here is that the PCR, the product category rule, is the rules by which the accounting is done to produce that statement, in this case for environmental impact, and that statement is the EPD. To date, the use of LCA is beginning. It's, what's the word, nascent, but it's increasing rapidly. At this point, pavement LCA has largely been implemented by research on case studies. It's generally been narrowly focused on greenhouse gas emissions and energy. Some tools have been developed and are available. At the network level, as an example, the California Department of Transportation has implemented greenhouse gas and energy LCA calculators into their pavement management system that allows them to evaluate those environmental impact indicators for different scenarios for pavement maintenance, preservation, and rehabilitation. The Illinois Tollway is way out in front on this, and they are developing a project-level LCA tool for use in design, for both mixed design and pavement design, it should say, and they're setting the groundwork for incorporating LCA into their contractor selection process. In the Netherlands was the pioneer, and France is moving ahead now. They use both LCA and cost analysis to select contractors for design build and design build maintain projects. The pioneer tool out there in North America was Palette, which was developed by Arpad Horvath at Berkeley. This provides inventory and impacts for 7 indicators for the materials and construction phases, does not include the use phase, includes some information about the end-of-life phases. PE2 has been developed by Amlan Mukherjee and his colleagues at Michigan Tech. It has a greenhouse gas emissions model for constructions, maintenance, and does include use phase as a function of roughness. Green Dot is a very high-level tool that's been developed by AASHTO. It's a high-level carbon calculator for operations, construction, and maintenance activities for state highway agencies. Not a great deal of detail, but helps you to evaluate some high-level policy decisions. Number of scholarly journal articles. We won't go through the laundry list here, but there is quite a bit of a literature building. Some of the subjects that have looked at is looking at binder materials for use in the construction phase. One of the things that we know is that if we exclude the vehicle use in the use phase, the main contributors to most of our environmental impacts are our binders that hold the stones together in the pavement, which are our asphalt and cement. And this includes the extraction and production of those materials, and to a lesser degree the transportation of those materials if we're hauling them long distances and by truck versus marine or rail. When we have high traffic, the vehicle use phase and the interaction of the pavement with the vehicle tends to dominate. We can look at that in terms of our traffic flow management for construction, which has been looked at by Santero, Mazinet, and Horvath. We can also look at the balancing the pavement life with the materials impacts. One of the things that we're trying to do in particular is take a look at the impacts of our construction quality specifications. And the very generally ignored, glossed over, but routine, mundane, but often the most important thing that we can do in the pavement construction phase is to improve our construction quality. And as I mentioned, pavement vehicle interactions on the high volume traffic roads is often our most critical. So wrapping up and taking a look at, based on the information that we've presented today, what are our recommendations? The first recommendation is that we should increase the use of LCA to evaluate the benefits as well as the potential unintended consequences of policy decisions before we move to implementation. As I mentioned before, there are often things that look good, sound good on a very high level, but when you get down into the details and take a full system look and a life cycle look, there may be places where implementation of a decision may be the wrong thing to do, and that's one of the things that we want to really evaluate, is that as we move forward to increase the sustainability of pavements, we don't take 2 steps forward and 1 step back because we haven't taken the time to really evaluate things. The next recommendation is to work on, and this is going to be some hard work, is how to integrate first LCA thinking, define the broad system, look at the life cycle, bring LCA principles as well as eventually the detailed calculations into pavement design, our procurement policies, and how we manage our pavements through our pavement management systems. Now, thinking in terms of the gaps that we need to fill, one of the most important is that we need to encourage and facilitate an active and comprehensive market for LCA data. And this is in particular where government can play a role at all levels. We need to, we recommend that we set up methods of encouraging the production of EPDs by the producers of the materials that we're buying for our pavements, that we support and incentivize the use and improvement of public LCI databases, and in some cases where different industries set up product category rules that have conflicts. One industry takes credit for recycling, another industry takes credit for the same recycling, which is what we call double counting. At times we may need an authority or a regulator to step in and resolve those conflicts. Some of the current gaps that should be addressed to make pavement LCA more useful to decision makers are to fill the gap of the need for improved models for pavement vehicle interaction, which is really moving forward right now. I think we'll have that essentially solved in the next couple of years. And then the next part is to be able to put this type of information on the desktops of pavement decision makers in a form that they can make use of. And finally, we need to think in terms of our contracting processes, how to bring LCA and combine it with life cycle cost analysis into our design bid, build, low bid project delivery process.
Thank you so much, John and Alyssa. I am excited now to hear from our guest respondents, Deepak Maskey and Heather Dilla. And I might point to Heather first to provide a perspective and reaction from industry on what John and Alyssa just shared.
Thank you, Laura. Before we open up the discussion, as Laura mentioned, I'm going to provide you a few comments on how the asphalt industry is responding and using LCA and how they view and see its importance. So essentially, over the past several years, the green construction industry is entering a new era focusing on measuring products' impact on sustainability. One of the most prominent examples, I'm sure all of you guys are aware of, is with the newest version of LEED, and where originally material credits were given to materials that were recyclable or reused, are now being replaced with a credit requesting that an EPD is produced. So as a result, the asphalt industry has created a new EPD program. It just started this year, or actually 2014 in September. And the goal of this program is to provide a comprehensive, credible, and comparable environmental data to customers, such as engineers, specifiers, users, and producers, to be used in future pavement EPDs, as John had mentioned. EPDs published through this program will allow decision makers to make informed comparisons among asphalt mixtures and ingredients, as well as with the goal to improving the overall environmental impact of pavements. In addition to this process, having industry involved in the LCA process is very powerful. This helps material manufacturers identify those hotspot areas that Kendall was mentioning, in which the material production process can be improved to reduce their environmental footprint. So essentially, we're moving towards actually designing for the environment, and LCA is a powerful tool towards that. Thank you.
Thank you so much, Heather. And Deepak, are you there?
Yes. Let me give one our mission. Our Caltrans, one of the mission is have sustainable payment, and with the sustainable payment covers both. It can be societal, it can be economical, or it can be environmental. And we are looking about environmental to how to build environmentally sustainable payment. But we need a tools, which is LCA gives us tools to decide to make a decision on project. So traditionally, we are only using LCCA to make any project decisions. But if we have LCA, then we can use that one for our project decision too. So we are looking how to combine LCCA and LCA sometime. So we are working with UC Davis with John Harvey to develop LCA. And we still feel certain gaps is there, as John mentioned, about information that is LCI on inventories that should be representing California. That is a really big task and very that will take a long time. And also we are looking for pavement vehicle interaction, and also we are looking for other informations regarding what tools we can use and how quick we can use it. That is really questions are there. And again, the big question is what threshold should we use? This is all in management level decisions. So we are working on that one. For meantime, we are working how to get LCA to use for California use. And in addition to that one, we are also involved in urban heat island effect indexes. So also we are looking at that one too from environmental perspective point of view, like a carbon emission and other stuff. So this information is really good for us, and we are looking forward to get more information and more input for our studies. So we are expecting to get really good information for Caltrans use. The big question is about how to use this LCA in project decision making. So and how to join to LCCA or other project decision making. So that is really a good question I want to ask John Harvey for California.
Great. Well, you threw out our first pitch for questions, Deepak, so I'll turn that to John and Alyssa to respond to.
Okay. The map, the roadmap that I'll lay out to some degree follows what's happened in Northern Europe and is now also happening with the Illinois Tollway. I think the first step is to begin to bring LCA, even before we have the data and the software, is to bring LCA, what we call LCA thinking, into our decision making. So that can be done with some fairly rudimentary assessment of flows. The two key things are to define our system boundary so that we consider all the things that will be affected by our pavement decisions. And then the second part is to take a life cycle view of that. So not just what's going to happen with the initial decision I'm making, but what are the repercussions of that in terms of future construction of maintenance and rehabilitation and preservation. So that's the first thing is, and then even just calculating quantities of materials over the life cycle, distances that we have to transport things versus recycling in place, quantities of binders that we're using, such as asphalt and cement, which from the materials point of view are the big hitters. That's the first step. The next step, which I think will be happening over the next couple, which I know is happening over the next couple of years, is development of tools, but more importantly, the encouragement and production of EPDs. This is really key. Heather mentioned the work that's being done on the asphalt side. The cement and concrete industries are out there getting going, producing their EPDs, getting their PCRs in place. Once we can get that information-rich environment out there, the development of tools that really support decision-making, the same way that we use software to support how thick the pavement is and how long it's going to last under different traffic conditions, will be there at our fingertips. So I think the key is that if we can fill those gaps that we talked about, particularly getting the inventory data out there and making it accessible and low cost, we will have tools to bring that in very quickly.
We have some other questions that participants are submitting. So I'll throw out another question to our presenters, and Deepak, Heather, you're also welcome to chime in on these questions as well. So we have one question asking to please talk a little bit more on how to fill the gaps on national and regional LCI and the public LCI database across regions and countries.
Yeah, so I can talk a bit to that. First, I think the evolution of EPDs and the fact that they are now being produced in much greater quantities in North America is going to really help get more public data out there that's going to be important for life cycle inventories. I also think that there needs to be a real effort on the part of a sort of a national effort to have publicly available life cycle inventory data out there. Certainly, the U.S. life cycle inventory, U.S. LCI, was produced quite many years ago by the National Renewable Energy Lab, and there have been some updates to it, but the way the data is presented is not very useful to average to practitioners who want to use it. So with that in mind, I think there definitely needs to be a role for some sort of repository that's at a national scale, but also think that the emergence of EPDs for a lot of important materials are going to help a lot.
Yeah, we have a great question about third-party verification. And so one of the parts of the ISO process is that when an industry produces a set of product category rules, that there's third-party independent verification of those rules, that they're following the ISO principles, that the processes make sense. In other words, an independent check that you're really following the appropriate procedures for doing LCA. So all PCRs should have independent third-party review, which is an ISO requirement. The cement and concrete industry, who've been a bit ahead on the production of PCRs and EPDs, have gone through that process, and a similar process is underway on the asphalt side right now. But third-party verification is a key component of that process.
I might chime in with a question myself. In talking about getting the data out there, making it available, and government having a role, who is best positioned? Is it FHWA, or who could really take a role on helping to facilitate that and make an active market for this data?
Well, I don't know too much about, I don't want to pretend expertise, but I know the US EPA has been working on an effort called OpenLCA with the goal of having a tool and publicly available data sets. I think this is the kind of exactly the kind of effort that's needed. We had another question about some information we presented on slide 31 when we talked about long life design.
Okay.
And we specified with the same materials.
So there's a question about on that slide. That was, and again, there's many scholarly articles out there. The idea here was, if we take a certain pavement, set of materials, thicknesses, a mass or volume of pavement materials that we're putting out there to carry traffic, if we can take those same materials and improve the construction quality, then we can get, that's one of the major ways that we can get an improvement in our environmental impact. If we can take a given pavement and make it last 10, 20, 30% longer through improved construction quality, that reduces by that substantial amount the amount of future materials that we need in terms of future maintenance and rehabilitation and reconstruction. I think the question is asking, well, what about comparison of different materials and different pavement structures? And there are, when you design a pavement, you have a trade-off in terms of how much materials that I use now and how much life I'm going to get versus building a pavement that will last longer, and I may take an initial higher cost and higher environmental impact, but because that pavement system lasts longer and in the future has less maintenance and rehabilitation, even though it has an initial higher impact over the life cycle, it may have a lower impact because of reduced maintenance and rehabilitation in the future. And I think that's a really good, another example of the kinds of things that can be quantitatively evaluated with LCA, is what is that trade-off of a higher initial impact versus reduced future impacts in terms of the overall impact over the life cycle. And that's really bringing that life cycle thinking into the decision-making process. I have one other question that came up earlier, which is how do we link LCA to life cycle cost analysis? And that's the kind of discussion we need to have as we're moving forward in terms of how do we make this, take it out of the academic world and the scholarly study world and get it into our day-to-day decision making. So there's two approaches for combining life cycle assessment for the environment and life cycle cost analysis. One, which has been used in the Netherlands, is to take the environmental impacts and come up with a system of trying to quantify those in terms of money, so that you add the monetary value of the environmental impact to the actual, over the life cycle, to the calculated agency costs and potential road user costs. So everything is in terms of units of money. There's been some, they've been fairly successful with that in the Netherlands. I think they're fairly happy with it. But there's been some critique of that approach, and an alternative approach is to do something similar to the way that we select the design-build contractor in terms of best value, where we come up with an equation that has weighting in it. We don't turn the environmental impacts into money, but we weight the environmental impacts and then combine those into a combined score with the life cycle cost. So two different approaches for combining life cycle assessment and life cycle cost analysis.
Now I might point to Heather and Deepak, or call upon both of you to see, do you have any other questions that you would like to ask of John or Alyssa, or to make any other points building off of some other questions that John and Alyssa have been responding to? We hear some rustling.
I think we got, John covered almost everything, all my questions, so I don't have questions.
Now, Deepak, I did have one question. During John's presentation, he did touch on, or his portion that he was presenting on Caltrans' use of using LCA for greenhouse gases and energy as a part of to understand the greenhouse gas and energy impacts as a part of your pavement management system. Can you expand on that and how Caltrans is currently utilizing that and what are plans moving forward?
I'm not familiar that one yet in that tool set. For a long time, it was not being used. So it depends on policy, but I'm not in position to answer whether that is being used.
Okay.
But it is there. John developed that one. Then John said it is there.
Well,
Caltrans right now it's just been put in the last year, so they're figuring out how to use that.
Now, state DOTs seem like natural users of using LCA as a part of their pavement management programs. Are there other front runners in the United States that are using, I think you mentioned, was it Illinois? Are there others that are kind of on the cutting edge of this that we should be looking to as leading the pack?
Well, I think the Illinois tollway is way out in front in terms of implementation right now, in terms of down in the nitty-gritty decision making. I know California is using this type of information more at a policy level and answering some higher level questions, and we haven't gotten down, as Deepak said, we haven't gotten down to the nitty-gritty. I think the other place that it's been used, and an example that comes from the concrete industry, is when they've been going through their whole processes and using LCA explicitly to identify in concrete pavement production and construction, where do we produce the most impact, and therefore where should we focus the most of our thought process in terms of trying to improve the sustainability of our processes. So I think that's an example of an industry that already has gone through and tried to figure out how can we recommend to preparing our industry and our producers for when this whole system gets set up, that people are potentially in the future choosing pavement types and such. How do we prepare our industry to identify the most important places to focus our attention, and what are the kinds of things that we can do to reduce our environmental impact? So I think on the government side there's a decision-making process, but I think industry, concrete industry, and now the asphalt industry is going that direction. How do they prepare their industry to be competitive in this environment where environmental life cycle assessment is being used in part of decision processes, both at the higher levels and down at the project design level and selection level?
Great. And then you touched on a little bit about what US EPA is doing, what FHWA is doing. Is there anything that we can share today that's happening at the federal level that would be of interest to those interested to see LCA to be advanced? I
think at this point, the Federal Highway Administration, and I don't speak on behalf of anybody other than myself, at this point, the main mission of the Federal Highway Administration is to get folks together, and this is part of what we're also trying to do through this series of pavement LCA symposia, is bring all the industries together, all the levels of government together, hammer through some of these discussions. How do we do this? Where are the gaps? How do we fill the gaps? The Federal Highway Administration's mission at this point is to get that information into documents and webinars and get it out there and take people up the education curve. First of all, they are not in a place at this point to mandate or regulate or make rules at this point. It's really more information and develop the technology so that we're ready to move in that direction. I think in terms of the actual implementation at this point, it's mostly at the state and local government level where this can make the most progress in the shorter term in terms of thinking through these Do we have enough information? Do we have the tools? If we do, then how do we start bringing those into our daily and annual decision-making processes? I think that's over at the local and state level right now, is where that should really move the most at this point.
Great. And we do have a couple more questions that have come in. One was to comment on what the expectations are for agencies and owners to embrace LCA, which I think you elaborated on just now. And the second one is to build off of a previous question. So is LCCA is much more mature and developed, several decades, but it still is not universally adopted by highway agencies. And maybe that's more of a comment than a question.
Well, that's a good. I can follow up on that though. I think having experienced and played a small part in the life cycle cost analysis implementation process, and particularly working on it in California, I think we can learn some lessons, positive and negative, from the LCCA experience, and I think that lays out some things we can do the same and some things we can do different. I think the things that we need to do the same as life cycle cost analysis is we need to customize the information so that it's regionally applicable, and the tools, decision support tools, are tailored to the language, the acronyms, the processes of each decision-making authority. Having generic life cycle assessment that's quote-unquote nationally applicable is kind of an oxymoron, because different language, different processes, different pieces of information, different impact indicators in different places will be somewhat different. On the other hand, the positive thing is having in that case, Federal Highways has really encouraged it, and Federal Highways has supported the development of a national tool which is customizable, and that might be a direction that we could go. I think on the negative side, a lesson learned from LCCA is, unless there are top-down decisions that say thou shalt rather than thou might, or thou shouldeth, or whatever the alternative is, getting to we want LCA information, we're going to use it in our decision-making process. If you don't want to do that, then you're not a player in the game, is eventually, when push comes to shove, what it takes to move things forward. And I know that's the direction that eventually has pushed things to real implementation for LCCA in some places. And when it hasn't happened, you have kind of a hand-waving, so to speak, of LCCA, but they're not necessarily using it in their decision-making process.
Great. Well, we are coming to the end of our webinar today. I do want to take a moment to thank our speakers, John and Alyssa, for joining us, as well as our special guest respondents, Heather Dilla and Deepak Maskey. We really appreciate you being on the call today. Just to let everyone know, this webinar does build off of the white paper that dives much deeper into everything that was discussed today, and that will be posted and ready for download sometime next week. Again, we'll send out an announcement to everyone when that is ready. And for those that would like to continue tuning in to the latest and greatest research that is coming out of the National Center for Sustainable Transportation, we invite you to join us on June 25th for a webinar on reducing the carbon footprint of freight movement through eco-driving programs for heavy-duty trucks. So thank you again for all of those that joined us today, and this concludes our webinar.